Today's lecture is about the torque acting on a current loop, or the turning effect produced in the current loop which is placed in a magnetic field. In the figure you can see a magnetic field which is directed from the north pole to the south pole. This is the direction of the magnetic field B, and the current loop is placed horizontally in this magnetic field B, and you can see that this current loop is carrying a current in this direction, that is, it is counterclockwise direction in which the current flows is in this uh, rectangular loop. Now, as you know that a current carrying wire experiences a force due to the magnetic field B, and that force is given by F is equal to ILB sine of theta, where I is the current flowing in the wire, L is the length of that wire, and B is the magnetic field B, or it is the strength of the magnetic field B in which that wire is kept. Now here, instead of a single wire, we are having a loop. So and next is theta. Theta is the angle between this L and B, and L is a vector which has a magnitude equal to the length of that wire segment, and its direction is the same as that of the conventional current flowing in that wire segment. So here L is this vector which is having the magnitude equal to the length of this wire segment, and its direction is this one, which is the direction of the current in this segment. So if we apply the left hand rule to determine the direction of the magnetic force acting on this segment of wire, we will stretch the first finger of the left hand in the direction of the magnetic field B. This finger represents the direction of the magnetic field B, whereas this finger, this is giving you the direction of the vector L. So this finger, the thumb will then give us the direction of the magnetic force acting on this segment of the current loop. Let me repeat it once again. How will we apply left hand rule to determine the direction of the magnetic force acting on this segment of wire? We will stretch the first finger of the left hand in the direction of the magnetic field B, which is this. So this finger, the first finger, is indicating B, the direction of B. The middle finger is giving you the direction of L, which is also the direction of the direction of the current flowing in this direction. So this is the direction of current, which is this. The stretched thumb will give you the direction of the magnetic force acting on this wire segment. So the thumb is indicating the upward direction. It means that the force on this current segment is upward. Actually, this finger is not showing L, it is showing I. The direction of L is the same as that of I, the conventional current I flowing in this segment. So this application of the left hand rule gives us the direction of magnetic force acting on this segment as the upward direction. Now come to the second segment, which is carrying the current I in this direction, because current is flowing counterclockwise, so here the current will flow in this direction. That is, this will be the direction of the current in this segment. So how will you use the left hand rule to determine the force on this particular segment of the current loop? You will stretch the first finger in the direction of the magnetic field B, which is this. This is the direction of the current, so this must point inwards, and then the downward stretched thumb will give you the direction of the force acting on this particular segment of the current loop. So here you see that the direction of the magnetic force on one segment is upward, whereas that on the other segment is downward. So if this segment is pushed upward and this is pushed downward, what will happen? It will start rotating. So there will be a turning effect produced in this current loop when it is placed in a magnetic field, and this gives rise to a torque on the current loop. Now such forces which have the same magnitude. Now here you can see here as well the angle between B and L is 90 degree, because this is being placed horizontally, and this is the side which is making an angle of 90 degree. This side is parallel, but this side is perpendicular. So that is why there will be no force acting on these two sides which are placed parallel to the magnetic field B. The angle between L and B for these two segments is 0, because theta between B and L is 0. So sine of 0 gives you 0, and the force will be 0, or there will be no magnetic force acting on these two sides, but the magnetic force acting on these sides will be maximum, because theta is 90 between L and B for these two sides. But the directions of the forces will be opposite, because L is directed this way for this segment and that way for this segment. So the angle is the same, that is 90 degree. The current is the same, the magnitude of L is the same, B is the same, theta is the same. So the magnitude of the force is the same, but the direction is opposite, because the current is reversed. The direction of the currents are opposite in these two segments. That is why the forces are also opposite. So such forces which have the same magnitude, but their line of action is not the same, this gives rise to a couple, and the couple causes the turning effect, or it produces the torque in this current loop.